the equation of a tangent line. And we have already talked about tangent line equations, but now we're going to relate it to derivatives. This formula right here, it's on your little note cards. You should have it memorized. I do not have a poster of the equation of a line. Like, that should already be in your brains.
Yeah, that's
It's point slope from Algebra 1. So y...
like 8th grade.
Yeah, or yeah, 8th grade for y'all, yeah. Y minus y1 equals mx minus x1. What do you mean?
Like, why is
Because we've memorized it before.
No, like, why is the point slope formula the same as a tangent line?
Because a tangent line is a line.
Okay.
And this equation of a line.
Does that not make sense?
I mean, I get what you're saying, but like a tangent line is just a linear line.
Okay.
And this is an equation of a linear line.
She gets what you're saying, but
No.
People watching the video are weird.
oh wait.
Okay.
Happy boy, you video?
Yeah, I'm videoing.
Where?
It's okay.
Like, I get it.
I don't know how
I
many people actually watch them, but just in case.
I do
There
when
you
I'm
go.
not here.
Yeah, when you're not here, but I think everybody was here today. So if
Yeah.
everybody's in attendance, does anybody go back
Everyone
and
go
watch
back
the
and
video?
You might as well just start.
Okay, no, we're starting now. No, we're talking. So when you're doing an equation of a tangent line, you do need x, y, and m. Now m is slope. How do you think we're going to find slope?
Y equals
Mm,
y2 minus y1.
no. What tells me slope? What's the new thing?
Rise of
Yes,
a run.
derivative. So the new thing that we have learned is to take a derivative, and the derivative tells us the slope of the tangent line. So when you're trying to find slope, we're going to take the derivative because the derivative will tell you slope. That's kind of how they relate from each other.
It literally told us the answer on the note.
It did. It's okay though. All right, so on 40. Find the equation of the tangent line for f of x equals x cubed plus 1 at x equals negative 1. So when I see these directions right here, find an equation of a tangent line. Off to the side, I like to write x, y, and m. Because I know that I need an x, a y, and an m to write the equation of a line. And it's got to give me one of them. Which one does it give me? X. It gives me negative 1. It gives me negative 1 as your x value. How do I figure out my y value?
Plug in the x into it.
Yes.
So,
Yes. Huh? Oh.
What's going on?
Elijah, this is why you lost your privilege to sit right there.
It's 0. I'm still sitting.
Oh, it was
Is the... No, it's not you.
Oh, it's probably under her binder.
This.
Oh, my bad.
You're good.
Wait, was it actually me?
No, it just times out after a while. Okay, so you're going to plug in negative 1 into the function, and so negative 1 cubed plus 1, which is going to give you 0. Okay, so I have my x, I have my y. How do I find slope? The derivative. Derivative.
Yeah, it's 3, right?
All right, so what is the derivative of x cubed? 3x squared. What's the derivative of 1? 0. So I'm not going to write anything. And what am I going to plug into the derivative?
Negative 1.
Negative 1.
How do we know that?
What did she just say?
All right, hold on, pause. So to find the slope, I take the derivative because the derivative tells me the slope of the tangent. Shh, Hannah, Cameron. Shh. The slope of the tangent. The derivative of x cubed is 3x squared. Okay, awesome. The derivative of 1 goes away as 0. And then this is my derivative. The x value that I'm going to plug in is the x value that was given, which is negative 1. Negative 1 squared is 1. Let's play a game. How many times can my notes get interrupted today?
Just kick him. So it's 3.
So 3. All right.
Do more.
Mm-hmm.
So now we just.
All right. So now that I have x and y and slope, Cameron, are you okay? Why? I don't even know why you're laughing. Okay. Y minus what's my y1 gonna be? 0 equals m. What's my m gonna be? 3. X minus what's my x1 gonna be? Negative 1. So it's gonna turn to a plus 1. You do not have to solve for y equals because when it says write an equation of a tangent line, this is an equation of a line.
Facts.
Yes.
So,
So
wait,
we-
so are we ever gonna have to do it? Or?
Probably not. Rarely. Sometimes on the multiple choice they have it in y equals, but
I So I have a question. But if we were gonna plug that in into the calculator to see what a tangent line is, would we then have to solve like bring 0 underneath and everything and distribute?
Oh yeah, if you wanted to type it in the calculator. Okay, and actually we can. So x cubed plus 1. Nope, not that calculator. Hold on.
Oh, your face got so red.
Yeah, he swells up like a pumpkin. No, I never said pumpkin swell. I said he ends up looking like a pumpkin. Pumpkin.
All right, so it's kind of hard to see on here, but if I graph my function, which was in blue, and then you see the red line was the tangent line graph that I just graphed, you see how it hits? Yeah, so you can see it on the graph.
So they meet, and that's
So they'll touch right here.
Wait, so you
Can you get him out of
Cameron.
His laugh is so weird. It's like breathy.
I don't even know why you're laughing
I
though.
don't know either.
No one knows why.
So you
We're gonna
plug
have
in
to
the
rewatch
x
the video.
cubed plus 1 and then plug
We're
in
gonna put the
the
timestamp.
slope formula for the y minus 0. And
Yeah, because you don't really need the -0, right?
Yeah.
It's just like y equals. So then I did the 3 parentheses x plus 1, and that's how I got the other line. Yeah. All right, let's try and do another one.
It took us 15 minutes to do one problem. It's pretty bad.
Yeah, seriously.
Okay. On 42, find the equation of a tangent line for f of x equals 3x to the 4th minus 2x plus 1 at x equals 0. So same thing, when I see the equation of a tangent line, I write x, y, and n. So if I'm trying to find the equation of a line, I know I need x, I need y, and I need n. Which one does it give me?
It gives you X.
Gives me x, gives me 0. When I plug in 0 into my original equation, I get 1. Right, because 3 times 0 minus 2 times 0 plus 1 is 1. All right, to find slope, what do?
Derivative.
Derivative, because the derivative tells me slope. So what is the derivative of this function?
12x cubed minus 2.
12x cubed minus 2. And what am I going to plug into the derivative? 0. So when you plug 0 into your derivative, what do you get? -2. So your slope is -2. And once you have your x, your y, and your m, then we can write the equation of a line. Y minus
1.
equals -2, x minus 0. Do you really need the -0?
No.
No, you
Well,
don't.
you
But
can
you
round it off.
you can write it. No, I won't count off either way. Uh-huh.
So how would we plug that in and check it? Would we move the 1 over?
Yeah, that one you would have to add 1
Okay, and so
So
then
you
it
would-
be -2x minus 1?
plus 1 because you would add it.
Oh, right.
Yep.
So the minus 0 doesn't take anything away from the x, right?
Right. Okay. So let's do a little bit of a harder example now. So go to 41.
How is 41 harder than 42?
I don't know. Just the way I typed them.
Probably gonna be from the
If f of x equals 2x squared, find the equation of the tangent line. So I'm seeing those directions again.
X, Y, and.
So x, y, m.
So it gave you the slope.
Yes. So this one says we are parallel to the line 4x plus y plus 3 equals 0. What do I know about parallel lines? Same slope. And what do I need to do to this equation so I can figure out what the slope is? Yeah, make it y equals. Because I got to put it in mx plus b. So I'm going to minus the 4x and minus the 3. Right, does that make sense? So I moved the 4x over and I moved the minus 3 over. So I got y by itself. Now that it's in mx plus b form, what is my slope? -4. Because parallel lines have the same slope. All right, so I have slope. Now I need to figure out what my x and my y are. So we're kind of working backwards now. So I'm starting off with slope. What else? What tells me slope?
Derivatives.
The derivative. So if I find the derivative, I know that the derivative should equal -4. Does that make sense? Okay. So what is the derivative of my function right here, the 2x squared?
4x.
Mm-hmm.
we got that. Wait. You just plugged in. What did you plug in?
I haven't plugged anything in. I've just taken the derivative
Okay.
of that guy. Now, we don't know what x is. That's what we're trying to figure out. What do I know this derivative has to equal? -4.
-1.
Yep. And once you get your x value,
Plug
Then
it
you
in.
just plug
Yes.
it into the first equation, like that one up there.
How did we get it? Because it's by the x.
yes, whatever
The
it,
derivative.
this like mx plus b.
Okay.
You plug in -1 to the mx plus b equation, or the
No, no, I'm sorry. You plug in -1 into the function equation you're trying to find the tangent line to.
that one.
So we'll plug -1 into the 2x squared. So 2 times -1 squared. Yep. So your y value is 2. Now that you have x, y, and slope, then we can write the equation of the tangent line. Y minus 2 equals -4 x plus 1.
Is Mr. Stahl an athlete?
He has a math shirt on today.
He said he didn't want to wear the heart one, but all the other ones were too small.
He tried this one on first. It was tight on him. And then I think my other one was even smaller. So he stuck with the extra large shirt. Okay. Let's look at 43. All right, 43 says, show that the graphs y equals x and y equals 1 over x have tangent lines that are perpendicular to each other at their point of intersection. All right, so it's a little different. Still talking about the tangent line. But for right now, I'm going to figure out where the point of intersection is. All right, because I know I can do that. What do I do to my equations to figure out where they intersect? Set them equal. So what would I do here to solve for x? Multiply by x, so I get x squared equals 1. Yep, so square root, so I get x equals plus or minus 1.
So that's like the XX.
Those are the x's. So I have x equals 1 and -1.
There's two.
There's 2.
Oh, great.
So you have to plug in both.
Well, kind of, yes. What's special about perpendicular lines?
For opposite slopes.
Opposite.
Wait.
What else? Opposite what?
It doesn't matter if there's two x's
Reciprocal.
because there's two x places, right?
This will make sense in a little bit.
Okay.
Just let it be for right now. All right, so opposite reciprocal, yes, very good. So I'm trying to check to see if my slopes are opposite reciprocal. Well, what tells me slope?
Y equals mx
The
plus
no
derivative.
Yes, derivative. Derivative tells you slope. So there's a pattern today. The derivative tells you slope. What is the derivative of x? 1.
Facts.
Why didn't they teach us this when we were doing regular slope? I don't know.
You didn't know how to do derivatives yet.
That's what I'm saying. They should have like introduced us.
A little bit, yeah, because
While our brains were still malleable.
right now you're all slope is mx plus b, slope is y2 minus y1. So we have to change that to be slope is derivative.
They should have done that while our brains were malleable.
Yeah. Now they're all solid and unchangeable. Okay, this next derivative is a little bit harder. I do strongly urge you to rewrite your fractions instead of trying to do it in your head. So I'm going to rewrite 1 over x as x to the -1. So the -1 is going to come in the front. What is my new exponent going to be? -2, which is the same thing as -1 over x squared. All right, so these are my two derivatives, which are the two things that tell me slope. Now, the blue one, right, the first function, is that derivative ever going to change? No, it's going to be 1. All right, so this first derivative, always 1, no matter what. For this derivative, when you plug in your x values to see what your slope is going to be, when you plug in the plus minus 1, what is the squared going to do?
Positive.
Turn it positive. And so then you are going to have -1 over a positive 1. Are these not opposite reciprocals of each other? Yep. So it proves it. So these are opposite reciprocals. Does that make sense?
That's where the plus minus one.
Yep. So
we
the
just-
squared will get rid of the plus
What
minus.
do we circle as our answer?
It's all kind of your answer because it's showing that, so it's all of it. So we don't circle anything, just like all of the work. Okay. On 18, it says find the equation of the tangent line of the graph f of x equals e to the x plus sine x at the point 0, 1. So we've got some e's now, but it is asking me to find the equation of a tangent line. So I'm still thinking, what is my x, what is my y, what is my m? We do. So on this one, it was nice. It gave me x and y. How do I find slope?
Derivative.
Yes. So what is the derivative of e to the x?
E to the
E to the x. What's the derivative of sine?
Cosine.
Cosine of x. And what am I going to plug in?
0.
0. So e to the 0 plus cosine of 0.
2.
Yep. So e to the 0 is 1. Cosine of 0 is 1. So 1 plus 1, which is 2.
So now write your formula.
Yep. So y minus 1 equals 2. X minus 0.
Yay. Wait, low-key, this isn't that hard.
Nope.
Cameron did shut up earlier because of that.
Bro, Cameron was like having a laughing attack.
Whenever I start to laugh like that, I cannot help but to laugh. So I,
Bro, his laugh was like breathy.
We're laughing at
Hannah. Okay.
Is that why I touched on like my asked you?
So we've got, it's really not a whole lot different here. The big thing that we're going to take away from this back is the horizontal tangents. So let's talk about those first. You are going to see horizontal tangents over and over and over again. And over and over again. Horizontal tangents have slopes of what? What are special about the slopes of these lines right here? It's 0. So if my tangent line is horizontal and the slope is 0, where is that occurring at? What is special? Or the mins and maxes. Which is going to be important. That's like a whole unit. We talk about how to find maxes and mins and things like that using the derivative. So that's going to come into play a lot in like 2 units, I think.
I just realized that on your video, we're gonna hear Cameron having a laugh attack in the
Yeah.
video that you post.
Yeah. Okay. Normal lines
That's embarrassing.
aren't really in calculus a whole. They're not on the AP test. You might see them in college and you might see them in physics. So I kind of wanted to talk about them at least once.
I didn't see it in physics. No, we didn't.
You do. It has to do with force. So you remember talking about friction and then gravity is perpendicular. So gravity is always a normal line because it's perpendicular with the force is perpendicular. Yeah. But if you start getting more into the mathy physics, the force becomes a
I
normal
think he
line.
just didn't tell us until
He
it was
doesn't-
called, but
yeah.
he did.
Yeah.
He's just like, so basically.
This is how you do it.
It's
He was
all
just like, this is how you
triangle,
do it.
that's
You
what
didn't tell
Oh,
us.
and guess who was the TA during me and Reese's period?
And then she had
It
a
was me,
physics
guys.
period the next class.
Okay.
The only student.
Hold on. I gotta focus. You can't talk about things like that. This is perpendicular
Every time.
to the tangent line. Yep. So normal lines are perpendicular to the tangent line. So like when you are applying this to physics, the tangent line is kind of like your friction force. And so the normal line would be your gravitational force. But like I said, you don't actually see normal lines on the AP test for calculus. Your professor in college might talk about it. So I wanted to at least mention it. And of course, we've already said that perpendicular lines have opposite reciprocal slopes. You might see something about perpendicular lines on the AP test. So they might say something about perpendicular and you have to know that it's opposite reciprocal. Is that not how you spell opposite? Why does it not like it?
Opposite reciprocal.
Okay. Okay, so let's look at 44. It says find the x values of any horizontal tangents. So on this one, I'm not writing an equation of a line. The directions on this one are telling me to find x values. Pay attention to what the question is asking for. That will help. So I know I'm looking for x. What is special about horizontal tangent lines? Slope is 0. And what tells me slope?
Derivative.
The derivative. So what is the derivative of this one? 8x plus 7. And what am I going to do with my derivative? Not plug it in, because remember we're finding, yep. So you're finding x, so we're looking for x. So we're not plugging anything in for x, we're trying to figure out what x is.
Negative 7 over 8.
Yes.
Whoa.
Okay. So how do we know that n is 0?
Horizontal tangent.
And then we plug that into the thing to get y.
No, that's it. It's just find the x values.
Oh,
This
okay.
is the x value, so then you're done.
Is there another one like this? 'Cause I don't like it.
I don't know if I have another one like this.
Equations are going
Are we
So you
doing
mean
all
on
of
the
these?
test?
No, I'm going to skip 45 because it's not on the AP test.
Are we doing
On the child
46, 47?
But the finite is gag.
Okay. On 46, it says let f of x equal x to the fourth and g of x equal x cubed. At what values of x do the graph f and g have parallel tangent lines? All right, what do I know about parallel lines?
They're the same slope.
Same slope. What tells me slope?
Derivative.
Derivative. So what's the derivative? What would f prime be?
4x cubed.
4x cubed. And what would g prime be?
3x squared.
3x squared. And what do you think I'm going to do with these two derivatives? Yes, set them equal to each other. Because when the slopes are the same, the derivatives will be the same because the derivative tells you slope.
So do you get all the x's on one side?
Yep. And then because we have exponents, we do need to move everything to one side, make it equal 0, and factor. So don't try to solve this by trying to get x by itself. You can't do that when you have like x cubed and x squared and things like that. So when you move everything to one side,
Take an x out.
yes, how many x's?
2.
Squared. And so then you get 4x minus 3. So the x squared goes out, you're left with 1. That x squared goes out, we're left with none. Do what?
X, yeah, the x squared equals
So
0.
it'd be 0 and then cos or 3/4.
3/4, yep. Yep, so the x squared gives you an answer. When you set x squared equal to 0, you get 0. And then the 4x minus 3, when you set that equal to 0, you get 3/4. So at both of these x values, and that's it, because the question is just saying at what values of x. So all we're looking for are the x values. And then you're done. Yep. If it said like at what points or something like that, and you needed the x and the y, you would just plug them back in. Sometimes it does, yeah. All right, and then the very, very last question, which is pretty easy. We're looking at this graph, and I want to determine what the derivative is at these specific points. So what is the derivative at A? 0. Because the slope of the tangent line is 0. What's the derivative at B? Also 0. What's the derivative at C? Also 0. What about at D? D and E. Why D and E?
Because it's a crevice.
Yes, cusp corner. And what about at E?
What the heck?
Vertical tangent, so also D and E. Also, what is the slope of a vertical line? 0.
No, the one x value that it's at.
Yeah.
No. The slope of a vertical line.
Undefined.
Undefined.
Crap. Oh yeah, because
Do you remember doing
the
the...
vertical line test?
Yeah, do you remember doing this in Algebra 1?
Yes.
Where this vertical line is undefined, that is 0?
Oh, yeah.
No.
No.
Y'all remember doing that?
Yeah, we did that
I
like
don't
once,
think I
I
did.
think.
Right, the U has vertical
Let's
lines,
write that
you just
down.
remember it. The Z is made up of horizontal lines. Horizontal lines are 0. I don't know, that's
Yeah.
how I taught my Algebra 1 kids.
You have Algebra 1 this year?
No, a couple years ago I taught Algebra 1. All right, questions?
Are you done recording now?
I'm done.